in this example, we are given the instantaneous velocity of particle as v is equals to 5 e to power t meters per second. And we are required to find the average acceleration and average velocity of particle between instants t1 equal to 2 seconds and t2 equal to 4 seconds. We are also given with the initial condition that at t equals to 0, initially the particle was at origin, that is at x equals to 0. Here we are required to find the average acceleration. As we know that average acceleration can directly be given as v2 minus v1 upon t2 minus t1. That is delta v by delta t. So here, as particle is moving in rectilinear motion in a straight line, we can directly state v2 and v1 can be given directly by the expression as at 2 seconds the velocity will be 5 e to power 2 and at 4 seconds it will be 5 e to power 4. So it can be directly written as final velocity is 5 e to power 4 minus 5 e to power 2 divided by 4 minus 2. So the result will be 5 by 2 e square into e square minus 1 meters per second square. This is the answer to first part of the question, that is average acceleration. If we find out the average velocity of particle between 2 seconds to 4 seconds, we know well that average velocity can be given as x2 minus x1 upon t2 minus t1, where x2 and x1 are the position of particles at final and initial instants. So we are required to find the position of particles at t1 and t2 times. So these can be written as, here v is given as 5 e to power t, so we can write dx by dt is equals to 5 e to power t. So we can write dx is equals to 5 e to power t dt. On integrating this expression with the initial condition that at t equal to 0, x was 0, say at time t equal to 2 seconds, particle was at position x1. So here we'll directly get the value of x1, that will be equals to 5. Integration of e to power t will be e to power t. This will be integrated from 0 to 2. So this can be given as 5 e square minus 5, because e to power 2 minus e to power 0 will be 1. Similarly, if we integrate the same expression from 0 to 4 seconds and this from 0 to x2, we'll get the value of x2 as 5. Again, e to power t remains e to power t. It will be integrated within limits from 0 to 4. So this will give us 5 e to power 4 minus 5. So we substitute the values of x2 and x1 over here. You can see that average velocity can be given as, this will be, this minus 5 gets cancelled out. It will be again 5 e to power 4 minus 5 minus of 5 e square minus 5 divided by 4 minus 2. So in this situation the result will be 5 by 2 e square into e square minus 1 meters per second. So you just have a look very carefully on the process what we are using, and this is a special function where we can see the value of average acceleration and average velocity are numerically equal. And here to find out the average velocity, we have calculated x2 minus x1. This can also be directly obtained by applying the limits from 2 to 4 and x1 to x2 will directly get the value of x2 and x1. That you can execute in your copy and verify whether you are getting the result or not.